A very important topic of the chapter 4 is equilibrium of bodies. This is a very important topic both from exam perspective and also as far as the understanding goes. Most of the students do not understand this concept clearly because they get confused between equilibrium and also the state of rest. As we go along, we will try to understand this important concept. Equilibrium is defined as if there are number of forces that are acting on a body. Let's take a body and then there are number of forces acting on this body. Let's say F1, F2, F3, F4, so on and so forth are the forces that are acting on this body. And then if there is no change in the state of rest, for example, if the body is in the rest, it should not show any change in the state of rest because of the application of these forces. Or if it is already in a motion, then there should not be any change in the linear motion or translational motion. In case if it is in a rotational motion, then it should not change, it should not show any change in the rotational motion. If it does that, then the body is said to be in equilibrium. So the body is said to be in equilibrium if the forces that are applied does not bring about any change in state of rest or state of motion. That motion could be linear motion or translational motion, or it could be rotational motion. So that's the definition of it. The major misconception that the students have about this equilibrium is that equilibrium, they think that it is at rest. If the body is at rest, then it is in equilibrium. No, that's wrong. That's not the complete definition of equilibrium. Equilibrium does not simply mean rest. No, it never. For example, if I ask you a question, let's say a car, if car is there and if the car is moving on the road at a velocity of 10 meters per second, and I ask you if this body is, if the car is in equilibrium, then if you say if the body is not in equilibrium, then that's wrong. A moving body can also be in equilibrium. Definitely a body which is at rest is in equilibrium, true, but it does not mean that a moving body is not in equilibrium. No, moving body also can be in equilibrium. Let's see how. What are the conditions of equilibrium? Very, very important. One marker is guaranteed from this conditions of equilibrium. There are two conditions that needs to be met to say that a body is in equilibrium. The first condition is sigma forces, that is the summation of all the forces must be zero. Summation of all the forces, that is sigma forces must be zero. And then summation of all the moments must also be zero. That means whenever there is a summation of all forces is zero, that means there is no motion at all. For example, if I take this body and then pulling this side with a 10 Newton force and pulling this side with a 10 Newton force, my summation of forces, that means sigma F, that is 10 minus 10, because one is in one direction and another is opposite direction. So if it is plus, that will be minus 10 minus. So 10 minus 10 will be 0. That means there is no motion in the body. True, that means sigma F is equal to 0. So that is what sigma F is equal to 0. It is not only that if sigma F is equal to 0, but also the clockwise movements and anti-clockwise must also be equal. It is not that the forces in one direction must be equal to the opposite direction, but also in the clockwise movements and anti-clockwise movements must be equal. That is defined as sigma moments is equal to 0. That means clockwise movements is equal to anti-clockwise movements. So whenever there is sigma F is equal to 0, the body does not move. Whenever there is a sigma M is equal to 0, the body does not turn. In fact, actually sigma F is equal to 0 does not mean that the body does not move, but body does not accelerate. That's a correct representation. Whenever there is a force is 0, that does not mean that the body does not move, but the body does not accelerate. We will see this concept. But otherwise, simple. Two conditions for equilibrium, body to be equilibrium. One, sigma F must algebraic sum of all the forces acting on the body must be 0, and then the clockwise movements must be equal to the anti-clockwise movements. So equilibrium is two types. One, it could be dynamic or it could be static. As I said, a moving body can also be in equilibrium. Example, a car moving with a uniform velocity. It's moving, but it is moving with a uniform velocity. So that car is in equilibrium. For example, if it is moving with a non-uniform velocity, then it is not in equilibrium. So uniform velocity is correct. But if it is a non-uniform velocity, then it is not equal, it is not in equilibrium. Why? Because whenever there is a non-uniform velocity, that means there is an acceleration. That means there is an acceleration. That is what the definition of non-uniform is. If there is an acceleration, obviously there is a force that is acting in it. Otherwise, why would anybody accelerate? Am I accelerating now? No, I am not being accelerated. If I am being applied on, if there is force that applies on me, then I will accelerate. So that means if there is an acceleration, definitely there must be a force. If there is a force, that means sigma f is not equal to 0. That means this is not satisfied. So uniform velocity means the body is in equilibrium. Non-uniform velocity means the body is not equilibrium. The equilibrium can also be static. For example, a beam balance or a block on the table. A block which is on the table is static. It's not moving. Is it in equilibrium? Yes. Why is it in equilibrium? Take a table and put a block here. If you see, the weight is acting downwards and then reaction force is acting upwards. Both are equal. So, if I calculate the summation of all the forces, that is equal to 0. Is there any turning effect on the body? No, the body is not turning. So, sigma m is equal to 0. So, both the conditions are satisfied. So, this block is in equilibrium. But what kind of an equilibrium is this? That's a static equilibrium because the body is not moving. Whereas the car is in a dynamic equilibrium because the car is moving, but car satisfies these two conditions also. There is no sigma f is equal to 0 and also the car is not turning. It is not turning. It's going in a translational motion. So there is sigma m is also 0. So car is in dynamic equilibrium. The same applies true for the beam balance also. The beam balance, if you see here, so that is the beam balance. So the beam balance works on the principle of moments, or the beam balance is in static equilibrium. There are two questions in your board exam based on beam balance. One is beam balance in a static equilibrium or a dynamic equilibrium? Very easy. The beam balance is not moving. Correct. There is no translational motion. So it's not moving. But is it in equilibrium? Yes. Why? Because the clockwise movements is equal to anti-clockwise movements. That is why both the pans are leveled. If either of them is more, then it would actually turn this side. So it's equal, so that's why it is there. The clockwise movements is equal to anti-clockwise movements, then sigma m is equal to 0. Similarly, is there any net force acting on it? No. That is why it is at rest, or it is not showing any translational motion. So sigma f is equal to 0, sigma m is equal to 0. So my beam balance is in equilibrium. That equilibrium is called static equilibrium. Very important question. And what is the principle on which my beam balance works? So my beam balance works on the principle of moments. Whenever the clockwise moment is equal to the anti-clockwise moment, and then both the pans are equal. When both the pans are equal, we know the weight in this pan by knowing the weight in the other pan. So in one pan we will put a known weight, in the other pan we will put unknown weight. When both the pans are equal, that is when the moments are equal. So my beam balance works on the principle of moments. Okay, what is principle of moments? That's a next point. So the principle of moments simply says my clockwise movements are anti-clockwise movements. When the body is in equilibrium, that is when my clockwise movements is equal to anti-clockwise movements. So the principle of moments is directly a correlation of the body being in equilibrium. If the body is in equilibrium, it satisfies two conditions. The second condition is also known as principle of moments. So principle of moments simply says in equilibrium. That is very important. Whenever the body is in equilibrium, only then you can apply the principle of moments. What does the principle of moments say? Principle of moments says when the body is in equilibrium, then my clockwise moments is equal to anti-clockwise moments. That is what it says. So if you want to write it in your very familiar terms, so usually you say W1 L1 is equal to W2 L2. That is your equation for the principle of moments. But that may not be sufficient for you to solve the numerical problem. So we will not memorize that formula, but rather we will approach the problems in a different way. But otherwise, principle of moments is applicable when the body is in equilibrium. That says simply the clockwise moments must be equal to the anti-clockwise moments. Based on this, the numerical will come. When we come to the numericals, we